So now, dear student, let us discuss about how an energy and a wavelength of a continuous X-rays varies when a stream of an electron interact with a nucleus. I will explain this with animated diagram, and afterward I will also explain mathematically that how the wavelength of how we can basically produce highly energetic uh, continuous X-rays from an atom, and that will be a mathematical representation how we can basically produce a shorter wavelength from the from the uh, from an atom in the form of a continuous X-rays. So that will be represented mathematically. The student, as I previously discussed, I'm considering again the example of a sodium atom. Please note that the interaction of a sodium interaction of a stream of beam of electron may take place in a different ways. Like the stream of a beam of electron may interact with this nuclei, but the distance of the stream of the beam of electron may be more than from the nucleus of an atom. So this means that if the distance between the nucleus of an atom and the stream of beam of electron is far away from each other, then this will result into emission of less energetic continuous excess, because the interaction of the electric field of lines of the or field of line of the positive charge nuclei is less with negatively charged electron. So the deceleration of the electron will be slightly less, and the excess emitted in this case will have a longer continuous X-rays wavelength. Like suppose if the electron which is interacting with a nuclei of the sodium atom, it has a 75 kilo electron volt energy, uh, and when it interacts with a nuclei, there may be a slightly decrease in kinetic energy of an electron around 10 kilo electron volt. This means about 65 kilo electron volt. So this small change in kinetic energy, or this small decrease of 10 kilo electron volt of kinetic energy, will result into an emission of a kinetic will result into emission of an continuous X-rays with slightly longer wavelength, because the acceleration is slightly decreased. However, in case if, dear student, if the electron interact with a nucleus in slightly closer way, like electron interact with the nucleus in a closer way, if the energy, let's suppose the electron is 75, electron beam is around 75 kilo electron volt. So when the electron stream beam of electron interact uh, in a closer way, then the field of line which are basically generated from positive charge nuclei will basically easily interact with the field of line of electron in an atom, and both the field of line of stream of electron and the nuclei will result into more decrease in kinetic energy of the incident stream of electrons. So this means that we will get an X-rays or continuous X-rays with slightly shorter wavelength if the electron move, if the stream of the electron pass through or pass near the nucleus of an atom. Like this, here we have a 75 initial kinetic energy of electron is around 75 kilo electron volt, and when the electron passes or stream of electron passes from the near the nucleus, then there will be a higher decrease in a kinetic energy of the electron. The decrease may be around 40 kilo electron volt. This means that the rest of the 35 kilo electron volt of energy, kinetic energy is converted into a continuous X-rays. So these X-rays will have shorter wavelength as compared to the X-rays, which continuous X-rays, which are produced by the interaction of the nuclei and stream of electron away in an atom. Now we can further, dear student, produce very shorter wavelength of continuous X-rays. The maximum shorter wavelength X-rays possible is in a case when the stream of electron basically transfer a total, or it is totally deaccelerated or totally stopped in an atom. So in that case, that electron can generate maximum amount of continuous X-rays. Let us explain. Consider again the sodium atom. Now here in this case, if the initial energy of the stream of a beam of electron is 75 kilo electron volt. Now when the stream of beam of electron passed near a nucleus, if the electron or stream of beam of electron stop somewhere inside the atom due to interaction of this nucleus, then the maximum amount of the energy, which is 75 kilo electron volt, will be transferred into a continuous X-rays. So we will get a very shorter wavelength of continuous X-rays in case when the incident stream or a beam of electron is stopped near the nucleus of an atom. Since the electron are not transferred or not moved away from atom, so that amount of the kinetic energy transferred will be 0 kilo electron volt. As you know that the amount of energy, the initial amount of energy according to law of conservation of energy, is equal to the final amount of energy. So this 75 kilo electron volt of energy will be totally transferred into a continuous X-rays, and then in this case we will get a very shorter wavelength continuous X-rays with highly energy. Student, please note that it is very difficult and even it is not possible to get a continuous X-rays with having an energy of an initial beam of electron, because the electron may be stopped inside the atom, but it have also other types of interaction, and that due to other types of interaction, that and some amount or very small amount of energy may be transferred in those interactions. So at the end of the day, usually we get slightly less amount of energy as compared to the initial amount of energy. However, in ideal case, the maximum amount of energy possible in the form of continuous X-rays is the initial amount of the energy from the stream of a beam of electrons. So now let us discuss about the wavelength, mathematically about the maximum and minimum amount of energy possible for a continuous X-rays, and what is the role of the potential source in generating a shorter and longer wavelength of continuous X-rays. So now, student, let us mathematically discuss about the wavelength of continuous X-rays. Since I know that continuous X-rays are produced when a stream or a beam of an electron interact with a nuclei of an atom. The energy of a stream of beam of electron is kinetic energy, and the energy of the stream of beam of electron will be Ke is equal to half into mv square. So this will be initial energy of the stream of a beam of electron. So when the stream of beam of electron interact with a nuclei, then the stream of the kinetic energy of the stream of beam of electron will decrease, and some amount of the kinetic energy will be transferred into continuous acceleration. So the final kinetic energy Ke final will be Ke dash, the decrease in kinetic energy, plus the energy which is emitted in the form of continuous acceleration. It will be energy of a continuous acceleration photon. So it will be a half into mv square, mv dash square, which is decrease in velocity of the beam of electron, plus the h into nu is the energy of the continuous acceleration photon. So the student, the change in this energy will be change in total energy will be change in total energy will be a half into mv square initial kinetic energy minus half into mv dash square the final kinetic energy equal to h into nu, the energy of the continuous X-rays photon. So consider this as equation number 1. Okay. Now the student, in case I have discussed that in order to get a very shorter continuous X-rays with a very shorter wavelength, you need the incident electron to be stopped near a nucleus in an atom. So this means that the total amount of energy will be transferred into a energy of the X-rays photon. So half into mv dash square kinetic energy term will basically it will become this term will become a zero in case if you want to produce a continuous access with very shorter wavelength. This means that equation 1 will become half into mv square equal to h into nu, which will be a maximum frequency. Okay, so initial kinetic energy will be equal to a energy of the photon or energy of the continuous access photons. So this means that in this case we will get a maximum amount of or we will get a very shorter wavelength of continuous access. Consider this as equation number 2. Now the student, please note that usually the continuous X-rays are produced in X-rays tube, and X-rays tube, the electron are basically in X-rays tube are produced when a very high potential is applied across the anode and cathode of X-rays tube. So due to potential difference, the stream or a beam of electron are produced inside the X-rays tube. So basically, the potential difference is responsible for a production of kinetic energy of the inside of the electron inside the X-rays tube. So this means that the kinetic energy is basically of electron is produced due to a potential difference. Then the half mv square, which is the kinetic energy, initial kinetic energy, will be equal to the potential difference into an electron, so ev. So this means that half mv square is is basically is produced due to an electric potential or due to potential difference between the electrode and cathode of the X-ray tube. So consider this as equation number 3. So now we can basically replace the half mv square with ev in equation number 2. So the equation number 2 will become ev into a half a new maximum. So now, dear student, as you know that the frequency is equal to nu is equal to c by lambda. So maximum frequency will be equal to c by lambda minimum. This means that a continuous X-ray photon, if it has a maximum frequency, then its wavelength will be minimum. This means that this equation number, consider this as equation number 4, then this equation number 4 will become EV is equal to H into C by lambda minimum. So lambda minimum will be equal to EV divided by HC. So dear student, please note that the term H by C, E divided by HC, these three terms are basically constant. Okay, E is basically represent a charge on electron, whereas H is a Planck constant and C is a velocity or speed of light, which is 3 into 10 to the power 8 meter per second. This means that this lambda minimum term, the lambda minimum, which is a wavelength of the continuous X-rays, depend on the acceleration potential of the electrode which are present in X-ray tube. The higher is the accelerating potential in the X-ray tube, the shorter will be the wavelength of continuous X-rays. So, and similarly, if the lower is the acceleration potential of accelerated beam of electron, longer will be the wavelength of continuous X-rays. Student, the lambda minimum of continuous X-rays is known as cut-off wavelength. Cut-off. Okay, this term is called cut-off level. So, in a simple word, the student, the continuous X-rays wavelength depend on the acceleration potential which is applied on electrodes, which is applied on cathode and anode of the potential source in X-rays tube. So this is all about continuous X-rays.